Welcome again. In this tutorial, I'll be talking about the stack in this series of tutorial. When you go to my site project.fpga.com, I made a very long explanation, the theoretical introduction to stack. But here I'll be going straight to the practical demonstration. This is the simulated circuit on Logisim. But you can also find the Velour code. I have them all attached on my website. You will see all the Velour code that made this stack calculator. So this is just a demonstration of stack calculator in Logisim. The Velour code can be found on my website projectfpga.com/stack. So this calculator has the ability to compute complex maths as long as anything. It can consist of plus, minus, division, subtraction, and whatever. It can solve maths of this, something like this: 2 plus 2 times 5 divided by 2, solves it and gives the accurate answer at the end of the computation. So at the end of this tutorial, I'll also do a demonstration to show how it works. So first of all, let me explain what the interface is all about. First, you have your clock and reset, which are always there for every complex circuit, Logisim circuit that has to store, or a synchronous circuit, sequential circuit. You have your clock and your reset. Then for every stack, whether a calculator or whatever, it always has the push and the pop. The push has to store and the pop has to remove. So you have this push button. The push button is used to push in this data here. So whatever data you have here will be pushed into this calculator to be computed on. So that's what this particular push button does. So whenever the clock is ticking and the push button is on, whatever you have in your memory data will be stored into the stack. So that's what the push and the data stands for. Then you have the address and this pointer. So you know that stack is a last in first out. So whatever you put last is going to be removed first. Whatever you pushed in last will be popped out first. So when in a situation where you want to jump to a particular point in memory, you want your pointer to point to a particular address instead of pointing to the last inputted data. So you are going to use this address. So you will use this particular address. You put the address here, then you have your pointer signal on for you to jump to a particular address. So this is just to showing you that the maximum address for this stack calculator is 1F. That is probably 2 raised to power 5. That's probably 32 inputs, but you can always extend it. I'll make that available in the Velour code to be able to extend the address, so you can add more figures. But 32 inputs is quite large enough or something. Then at the output, you have your is empty. I explained what the is empty stands for on my website. You use this is empty. The is empty signal turns on at the end of the computation. It pops up and tells you that the calculator is done computing. Then your answer appears here at the peak. Peak means pick the top of the stack. That is what is at the top. The last data there, which is your final answer, will be here. You'll be able to see your peak here. So at the end of this series, I'll do a demonstration of what this stack calculator looks like. We'll do a particular example to show in what it does. So subscribe, like, and watch the next tutorial. Thank you.